Welcome to Astronomy Daily, your go-to source for the latest happenings in space and astronomy. I'm Anna.
And I'm Avery. We're thrilled to have you join us for today's episode, packed with fascinating updates from around our universe.
We've got a lot to cover, from SpaceX's incredibly speedy trip to the International Space Station to some intriguing new findings at Cern that could shed light on one of the universe's biggest mysteries.
Plus, as always, we'll be sharing our top tips for what to look for in the night sky this month, including a stunning planetary conjunction and a famous meteor shower. So let's dive right in.
First up, let's talk about an impressive feat from SpaceX, which just delivered a new crew to the International Space Station in a lightning-fast 15 hours.
That's incredibly quick, Anna. For context, that's just over half a day. The 4 astronauts, a mix of U.S., Russian, and Japanese crew members, launched from NASA's Kennedy Space Center and arrived at the orbiting lab feeling pretty good, I imagine.
Absolutely. Mike Fincke, one of the NASA astronauts, even radioed "Hello, Space Station" as soon as their capsule docked high above the South Pacific. They're set to spend at least 6 months up there, swapping places with the current crew who've been aboard since March.
What's really interesting about this particular crew are their backstories. Zina Cardman and Mike Fincke from NASA, Japan's Kimiya Yui, and Russia's Oleg Platonov each had quite a journey to get to this mission.
That's right. For Cardman, she was pulled from a SpaceX flight last year to make room for the 2 NASA astronauts who ended up stuck on the station due to the Boeing Starliner issues, Butch Wilmore and Suni Williams.
And speaking of Starliner, both Mike Fincke and Kimiya Yui had actually been training for the next Starliner mission. But with Starliner still grounded by thruster problems and other issues, potentially until 2026, they switched over to SpaceX. It's a clear sign of how dynamic and sometimes unpredictable spaceflight scheduling can be.
And Oleg Platonov, the Russian cosmonaut, has his own story too. He was bumped from a Soyuz launch lineup a couple of years ago due to an undisclosed illness, so it's great to see him back in action.
It really is. With their arrival, the International Space Station temporarily has a population of 11. Imagine that many people living and working together in that confined space.
Zina Cardman expressed her awe once on board, saying, "It was such an unbelievably beautiful sight to see the space station come into our view for the first time. It just goes to show that even for seasoned astronauts, the wonder of space never fades."
And while this 15-hour trip was speedy by U.S. standards, it's worth noting that the Russians still hold the record for the fastest trip to the space station, clocking in at a lightning-fast 3 hours. Quite a difference.
Following up on that speedy delivery to the ISS, there's been some significant diplomatic movement in space this week that we need to talk about.
You're talking about the first high-level face-to-face meetings between NASA and Roscosmos in almost 8 years, right? This is a huge deal, considering the last time their leaders met was back in October 2018, which was before a lot of the major geopolitical shifts and leadership changes on both sides.
Exactly. The relatively new head of Roscosmos, Director General Dmitry Bakhanov, actually visited the United States. He was here to view the launch of the Crew 11 mission, which included the cosmonaut Oleg Platonov we just mentioned, and he also met with some of NASA's human spaceflight leaders in Houston.
What's particularly striking about this visit is the disparity in how it was covered. NASA barely mentioned it, providing almost no public coverage. But the state-operated Russian news service, TASS, published multiple updates, clearly wanting to highlight the interaction.
It definitely points to a different agenda. TASS reported that Bakhanov and acting NASA Administrator Sean Duffy discussed the future of the International Space Station at Kennedy Space Center. Bakanov was quoted saying they agreed to continue using the ISS until 2028 and would work on the deorbiting process until 2030. They also reportedly discussed potential collaborations beyond 2030. Before Bakanov's visit, there was speculation that relations might cease entirely after the ISS's demise. So this suggests a potential shift towards some kind of ongoing partnership.
This brings us to what's been termed Russia's charm offensive with NASA. It's clear Bakanov wants to reestablish warmer relations. But the question is, why now? What's driving this push?
Well, there are a few interesting theories floating around. One highly speculative angle involves internal Russian politics. Bakanov is reportedly popular in Russia, and he's managed to navigate a very complex political landscape, especially given the recent dismissal and tragic death of a former colleague from his transportation ministry days. His very public trip could be seen as a way to bolster his image and show strong international ties.
That's quite a twist. But on a more direct space-related note, a significant motivation might be tied to the International Space Station's deorbiting contract. NASA awarded SpaceX a nearly $1 billion contract a year ago to ensure a safe deorbiting of the station into the Pacific.
And before that, NASA and Roscosmos had actually considered using 3 Russian Progress vehicles for the deorbiting. However, NASA ultimately decided that the Russian vehicles would not provide sufficient margin to lower the public risk to an acceptable level.
So Roscosmos, under Bakanov, has apparently been urging NASA to reconsider using Russian vehicles, and there might be some interest from certain White House officials to reduce reliance on Elon Musk's companies for federal contracting, especially after some reported falling out between President Trump and Musk a couple of months ago. Although NASA's press secretary was not aware if this specific issue was discussed.
It's a complex web of motivations for sure. Another key factor is NASA's current reliance on SpaceX's Dragon spacecraft for crew transport to the ISS. Boeing's Starliner vehicle isn't expected to fly crew again until 2027, and it's unlikely to be price competitive with Dragon.
So, having Russian Soyuz spacecraft as a viable option could provide NASA with a crucial means of avoiding a SpaceX monopoly on crew transport, especially as they look towards commercial space stations in the 2030s. It provides leverage and redundancy in their access to space.
It makes a lot of sense from NASA's perspective to keep their options open and maintain diverse access to space. It's not just about one mission, but the long-term strategic needs for human spaceflight.
Absolutely. This visit, despite the geopolitical backdrop, highlights the unique collaborative nature of space exploration and the enduring need for international partnerships, even when things are tense on Earth.
From navigating geopolitical tensions, let's shift our focus to an even grander mystery: why our universe exists at all. A groundbreaking discovery at Cern could bring us much closer to answering one of the most fundamental questions in physics.
You're talking about the new findings from the Lhcb experiment, aren't you? This goes right to the heart of the matter-antimatter imbalance, which is just mind-boggling when you think about it.
Exactly. The core problem is this. According to our cosmological models, the Big Bang should have created equal amounts of matter and antimatter. And if matter and antimatter meet, they annihilate each other, leaving behind nothing but pure energy. So, if that were strictly true, our universe should just be a cosmic soup of energy, with no stars, no galaxies, and certainly no us. But obviously, that's not the case. Astronomical observations show that our universe is overwhelmingly made of matter, with hardly any antimatter left. This tells us that matter and antimatter must behave differently somehow. There has to be some asymmetry that allowed matter to survive and dominate, while antimatter largely vanished. Our best theory of fundamental quantum physics, the Standard Model, does account for some differences between matter and antimatter, but these differences are far too small to explain the vast imbalance we observe. And that's where the new discovery comes in. The Lhcb team at Cern has reported finding differences in the decay rates of matter particles called baryons compared to their antimatter counterparts, antibaryons. For context, baryons are particles made of three quarks, like protons and neutrons, which make up most of the known matter in our universe. Antibaryons are made of three antiquarks. Previously, we'd seen differences in particles like mesons, which are made of a quark and an antiquark. But this is the first time these differences have been observed in baryons, which is hugely significant because they're the building blocks of most of the visible universe.
Specifically, they studied over 80,000 Lhcb baryons and their antibaryon counterparts. They found that these matter baryons decayed to specific subatomic particles, a proton, a kaon, and two pions, about 5% more often than the same process happened with the antiparticles.
5% difference might sound small, but it's statistically significant enough to be the first direct observation of different behaviors between baryons and antibaryons in their decay.
So, while this particular measurement is still consistent with the Standard Model's predictions for such small differences, the fact that we've now observed this asymmetry in the type of particles that dominate our universe is a monumental step. It supports the idea that there must be additional fundamental particles or effects beyond the Standard Model that cause the universe to exist in its current form.
Like finding a crucial piece of the puzzle. This discovery doesn't solve the whole mystery of why matter won out, but it points us in the right direction. It gives physicists a new avenue to explore for signs of that new physics that could finally explain the cosmic asymmetry after the Big Bang.
It's incredibly exciting. With more data from the Lhcb experiment, scientists hope to forensically study these differences and, potentially, tease out the definitive signs of those new fundamental particles or forces that are currently beyond our grasp.
Very small to the very large. Let's turn our attention now to something you can observe yourself, the August night sky. There are some fantastic sights to behold this month, even with the moon getting in the way of one of our favorite annual events.
That's right, Anna. Kicking things off, Jupiter and Venus are putting on a show. They'll be shining brightly in the east each morning before sunrise, with Venus appearing particularly brilliant. The real highlight for these two is their close meetup on August 11th and 12th, when they'll appear just about a degree apart.
It's a beautiful conjunction happening against a backdrop of familiar bright stars like Orion, Taurus, and Gemini. And later in the month, around the 19th and 20th, a slim lunar crescent will join Jupiter and Venus in the eastern sky, creating another stunning view before sunrise.
Now, about that moon interference I mentioned, the annual Perseid meteor shower, which usually peaks overnight on August 12th into the 13th, is unfortunately going to be hampered this year. The moon will be nearly 84% full on the peak night, and its glare will wash out all but the brightest meteors.
It's a bit of a bummer for Perseid enthusiasts, but you might still catch a few bright ones in the pre-dawn hours. The good news is that the Geminids, another fantastic annual meteor shower in December, is set for moon-free viewing, so we have that to look forward to.
Beyond meteors and planets, August is also a prime time to observe one of the easiest to spot nebulas in the sky, the Dumbbell Nebula, also known as M27. It's located high overhead on August nights.
The Dumbbell Nebula is a type of object called a planetary nebula, though it has nothing to do with planets. It's essentially a giant cloud of gas and dust that's been shed by a star like our Sun as it reaches the end of its life. Once nuclear fusion ceases, these stars blow off their outer layers, leaving behind a small, hot remnant called a white dwarf.
That white dwarf then emits a lot of bright ultraviolet light, which illuminates the expanding shell of gas, causing it to glow in visible light. The Dumbbell Nebula, named for its shape, appears as a small, faint patch of light in binoculars or a small telescope.
You can find it within the Summer Triangle, a prominent pattern of stars in the August sky. It's about a third of the way between the bright stars Altair and Deneb. It's truly a glimpse into the future of our own sun, which will undergo a similar transformation about 5 billion years from now.
It's a powerful reminder of the cosmic cycle that seeds the galaxy with the ingredients for new generations of stars and planets, potentially even ones not too different from our own. It's a beautiful sight and a profound thought.
And that brings us to the end of another fascinating episode of Astronomy Daily. We've covered everything from quick trips to the ISS and diplomatic dances in space to the mysteries of antimatter and the beauty of our night sky.
It's been an absolute blast as always, Anna. We hope you've enjoyed diving into the latest space news with us. And remember, there's always something incredible happening above us.
Absolutely. So keep looking up. You can find Astronomy Daily wherever you get your podcasts, and be sure to follow us on social media for more updates and behind-the-scenes content.
Thank you for tuning in. We can't wait to share more cosmic adventures with you next time.
Until then, this is Anna,
And this is Avery.
signing off.